Imagine this. You leave Earth in a straight line and never turn around. Do you loop back and arrive home after a cosmic lap? Do you fly forever through endless space? Or do you slam into a literal edge where space and time simply stop? That question isn't science fiction, it's one of the deepest puzzles in cosmology, and tonight we're going to unpack it in a way that actually makes sense. If you're into mind-bending space stories told clearly, tap subscribe and stick around. Short and sweet, let's go. Start with something deceptively simple. Why is the night sky dark? You might say, because the sun's on the other side. But even when the sun sets, the universe is crammed with stars and galaxies in every direction. If the cosmos were infinite, static, and eternal, then no matter where you looked, your line of sight would eventually hit a star. The sky should blaze like the surface of the sun, and yet, it doesn't. That contradiction has a name, Olbers' paradox, and the way we solve it will point us straight at the true shape and size of the universe. Roll the clock back to the beginning. About 13.8 billion years ago, the universe as we know it erupted into existence, hot, dense, and expanding. Not an explosion into empty space, but space itself stretching, carrying matter and radiation along for the ride. When we look far out, we peer far back in time, and we notice a rule that becomes the backbone of modern cosmology. The farther a galaxy is, the faster it appears to recede from us. That's not the galaxy racing through space faster than light. It's space between us and the galaxy expanding. This expansion creates a subtle but crucial horizon. There's a distance beyond which the fabric of space is expanding away from us faster than light can cross it. Light emitted today from beyond that boundary will never reach Earth. Cosmologists call a related distance the Hubble sphere. Here's the twist. Because the expansion rate changes over time, light that left some galaxies long ago can drift into the safe zone and eventually arrive after a very long journey. That's why we can still see objects that, right now, recede from us faster than light. The practical consequence of all this is the observable universe, the giant bubble of everything whose light has had time to get here since the Big Bang. It's not 13.8 billion light-years across. Thanks to expansion, it's closer to 93 billion light-years in diameter. That's our visual limit, not necessarily the universe's physical edge. Back to the dark sky. As space stretches, light waves stretch with it. Blue light slides to red, then into infrared, and beyond, lengths our eyes can't perceive. Distant galaxies become so redshifted that, to human vision, they all but vanish. That's the elegant fix for Olbers' paradox. The sky isn't bright like the sun because the universe expands, its age is finite, and much of the light is stretched out of our visible range. So, does the universe end? To answer that, we need geometry. At the largest scales, space-time can have one of three curvatures: positively curved, like the surface of a sphere; negatively curved, like a saddle; or flat, like an endless sheet. General relativity tells us that matter and energy bend space-time. The trick is measuring how the cosmos is bent overall. The test is delightfully simple in principle. Draw the biggest triangle you can, from imprints in the afterglow of the Big Bang, the cosmic microwave background, and add up its angles. More than 180 degrees points to positive curvature. Less than 180 means negative. Exactly 180 means flat. When we take that measurement, the result is stunning. On the largest scales we can probe, space looks flat. Not billiard table perfect, but so close that, for our purposes, straight lines stay straight. Flatness doesn't immediately tell us whether the universe is infinite or finite, though. Picture Earth. Stand in a field and it feels flat, but zoom out and you see the curve. Similarly, it's possible that our observable patch is just a tiny bit of a much larger, gently curved, finite cosmos, something like a higher dimensional sphere. In that case, flying straight long enough could loop you around without ever hitting a boundary. The other option is that space is truly infinite, the way a mathematical plane extends forever. Many cosmologists lean this way because it fits our measurements cleanly. flat geometry, no detectable wraparound patterns, no repeating signatures at the scales we can see. But infinite is a word that invites some unsettling consequences. If space extends without end and the laws of physics are uniform, then matter gets arranged in every possible way, given enough room. That implies repetitions, not just similar solar systems, but duplicate patches of cosmos. The mind-bender is that somewhere inconceivably far away, there could be a region nearly identical to our own, down to another you, watching a video just like this one, pausing it at a slightly different moment. The nearest exact replica would be stupendously distant, so far that for all practical purposes, it may as well not exist. But the idea flows from the math of infinity and the finiteness of possible arrangements of particles. Before that gives you an existential chill, let's pull back to what matters for us: horizons. Because expansion accelerates, most of the galaxies we can currently see are already slipping beyond a boundary we can never cross physically. Even if we built a ship that cruises arbitrarily close to light speed, the space between us and those galaxies expands too fast to bridge. Every second that ticks by, more stars pass beyond our reachable horizon. Far in the future, think trillions of years, the light from distant galaxies will fade below visibility. To late-arriving astronomers, the universe would look like a lonely island of one galaxy in an endless, empty night. They would never deduce the Big Bang from observations because the clues would have receded into darkness. Strange as that future sounds, it doesn't make our present any less extraordinary. Right now, we live in a golden observational era. We can read the afterglow of the Big Bang like a fossil record. We can watch galaxies in every stage of life. We can map the cosmic web. If this kind of cosmic context lights you up, drop a quick like. It really helps this channel reach more curious minds. Let's circle back to the 3 opening possibilities and make them concrete. Could you fly straight and loop home? If the universe is finite and positively curved on scales vastly larger than we can observe, then yes, in principle, but the time scales would be laughably beyond human or even stellar lifetimes, and accelerating expansion may prevent the loop from ever closing physically. Could you fly forever without looping or stopping? Absolutely. If space is infinite and flat, a straight line is an eternal journey with no edge and no repetition you could ever test. Could you hit a literal border where space ends? Our best physics says no. There's no evidence of a material wall, and the equations that describe space-time don't suggest a hard boundary. What we do find are limits to what we can see or reach, not limits to what exists. This distinction is vital. The observable universe is not the universe. It's our current light cone, the portion of reality that has had time to reveal itself. Beyond it lies more universe, likely a lot more, whose light either hasn't arrived yet or never will. That's why any diagram that draws a hard circle and labels it the universe is missing the point. The true cosmos may be vastly larger than our horizon, perhaps infinite. So how do we know flatness isn't an illusion? Couldn't we be fooled by a clever topology where space is finite but wraps around in non-obvious ways, like a 3-dimensional video game map that teleports you back when you cross an edge? Cosmologists actually look for repeating patterns in the sky, say matched circles in the cosmic microwave background, that would betray such a wraparound. So far, the sky doesn't show those repeats at the scales we can resolve. That doesn't rule out all finite topologies, but it pushes the simplest ones far beyond the size of our observable patch. In short, if the universe does loop, the loop is unimaginably big. What about the night sky again? The emotional piece of all this. The darkness you see overhead isn't emptiness, it's information. It tells you the universe has a history, that light has been stretched by expansion, that you live in a cosmos that evolves. Every pinprick of starlight is a timestamp. The darkness between is a record of distance and time too vast for human eyes to resolve. That shiver you feel when you look up, it's your brain catching a glimpse of that reality. There is, of course, room for surprise. Our measurements say flat, our models say no edge, and yet science grows by confronting anomalies. Improved maps of the cosmic microwave background, deeper galaxy surveys, gravitational wave observatories, all may sharpen the picture or nudge it in new directions. That's not a weakness, it's the strength of the scientific method. Bold claims checked against unforgiving data. So where does this leave you, the traveler in that thought experiment spaceship? It leaves you in a universe with no cliff to fall off, no painted backdrop to bump into, and no easy loop to guarantee a scenic return. It leaves you in a cosmos where the only true borders are the ones set by time, light, and the accelerating stretch of space itself. The edge you might one day reach isn't the end of existence, it's the end of your ability to gather more information. And that, weirdly, is hopeful. Because within our cosmic island, there is more than enough to keep humanity busy for eons. Stars to study, planets to find, life to search for, physics to uncover. Whether the whole is finite or infinite, whether space loops or runs forever, our small patch is already a cathedral of mysteries. If this expanded tour of the universe's shape and horizons clicked for you, share it with a friend who loves big questions. And tell me in the comments, does the idea of an infinite cosmos thrill you or freak you out? Before we wrap, let's answer the personal version of the opening question. If you set off today, straight as an arrow, where will your journey end? Not at an edge, not in a loop you live to complete. Your voyage will end, like every human story, in the time you have. But in that time, you can cross a different kind of horizon, understanding. You can learn why the sky is dark, why galaxies flee, why triangles in ancient light tell us the truth about space. You can, in your own way, trace the outline of everything. And if that makes you want to keep exploring with us, make sure you're subscribed. We've got more deep dives coming, clear, grounded, and just a little bit mind-melting. Thanks for watching, and keep looking up.